but in parentheses, and what's in front of it? Negative. So look, this is a negative root. This is a positive root. When you multiply a positive times a negative, you get negative. And then the root times the root goes away, doesn't it? And you're left with what's in there in parentheses. So that's critical. Your middle terms cancel. And you're left with log base A of x minus x plus 1, right? Because this becomes minus x plus 1. There's an x out here.
Oh, so you distribute.
Yeah, distribute that negative through.
So the x's cancel.
So the x's cancel.
So it's just log 1. That's 0.
0. Good. So that's just a very complicated way of writing the number 0, I guess, if you wanted to.
It's like, how much money do you have? Right here, sweetie.
Right here. This is it. Looks like a lot, doesn't it? It's nothing, though. The problem, this is actually problem 102 in the book, in this section for 6.5. And they actually, in the problem, say show, they actually say show that this is 0. That's the instructions. They say show that that's 0. Do you see how you do that? You just condense it down, and you go, oh, yeah, it's 0, check. It checks out.
Yeah, you should do that to your wife. That's kind of fun. You should be like, hey, honey, I need to go shopping. What's my budget? And she's like, here you go, this is smart. Once you figure out this equation, like, that'll tell you how much money.
I'm in a relationship where she doesn't ask me for money. I don't ask her for money. So we have money that's ours and we have money that's ours, you know? Like we have a shared account and then we have our own accounts.
Yeah, we're the same way.
So, all right, difference quotient. Do you remember this thing? Uh-oh. Oh, yeah. Don't forget this thing. Way back in the day, before spring break, way back, before that, I said there's this thing that we use in calculus all the time, and in this class we want to make sure we're comfortable computing that difference quotient. Later on it'll have more meaning to us. Right? Not yet. No, later on it will. But now we have a new function, and we should be able to do a difference quotient on this new function. So what I'd like for us to do is let's find this. Okay, so find the difference quotient for the function f of x equals log base A of x.
Okay. Wherever there's x, you plug in log base of x.
Not quite. Be careful with that. Okay, so remember, this difference quotient is universal, right?
Right.
Someone has to give me a function, and then I can compute this. I have to compute 3 things: top left corner, top right corner, and then the bottom is always h, so I don't have to compute it. But there's 3 main pieces: top left, top right, bottom. Top right is right here, given to me. Bottom is always h. Top left is that function with x plus h plugged in, right?
Yes.
Okay. So this difference quotient becomes f of x plus h, which you just said was, bless you. We've missed that. I'm speaking for everyone. Sorry, just me. Minus, so isn't this, take this function, plug in x plus h, and you get this, right? That's the top left. Minus log base A of x all over h. Now, what you're supposed to be able to do is simplify. And I don't know if you remember, the idea was to try and get that h to cancel out at the end. Don't know if we're going to be able to, but let's see what we can do with this.
Well, we can
You'd still have division by h.
Can you condense?
Condense how?
Yeah, but you still have the
You're right,
H6.
yes.
Yeah, condense the top part. then it-
2 logs, subtraction. Yeah, you can do that. Okay, let's see. So we get, maybe, let's see what happens. We have, you're saying the top is going to become a single log?
Yeah.
And then division? Is that what you're saying? Division? And it'll be what on top of what here? Over x, like that, all over h. All right. Nope, not quite. A little bit more. Nope, can't cancel those because it's 2 terms on top, 1 on the bottom. You could split it into 2, though. That you're allowed to do. Let me just see if you agree with this or not. Do you agree?
Hold on.
Okay, so this is what you were suggesting. You were suggesting that we take this h and we flip it up top, right? That h is really an h over 1, so if you flip it up top, it actually becomes a 1 over h up top, doesn't it?
Right.
That's that.
So we can do that.
So I just
You,
did it
you can, right? I mean, like, you don't disagree
so
that I could do that?
early.
Algebraically? Okay, so look, if I say take the number 3 and divide it by 2, that's the same as saying 3 times a half, right? Because I'm taking the 2 and looking at it like 2 over 1, and then I'm flipping it up and I'm doing this. So I can do that algebraically. Now, why would I want to do that? Anyone see what I can do now?
And then you can put that on top.
Good. I can push that 1 over h as a power up top, can't I? Because this is like a coefficient now. I can push this up on the log. Good.
So you should wait to multiply with that H before you combine.
Yes, yes. You could have still done it the other way, but it just would have had to have waited before you could push it up.
So then would be log of a,
Log base a,
yeah, then the square root of h
Of-
of x plus h divided by e?
it would actually be the h root,
Yeah,
not the square root.
Yeah.
Yeah. But let's leave it like this. I'm gonna just say this is our answer, okay? This is it right here. That's what our difference quotient is.
Well, let's say it's with a test question. Would you ask us to do it?
This is not necessarily like a test question. What this is to get you to see that when you get to calculus and your teacher's up on the board doing all this shit, you're like, what are they doing? And they're not talking about condensing and okay, and what can we do with that h as a power? They're just doing it, and you're like, what in the world's going on? This is the type of thing you can do with condensing and with these properties. Transform something, put things together, flip, bring it up. I mean, that's all fair game now.
You can make sure to remember.
So just make sure you're not just watching that happen in a class down the road going, what are they doing? Like that's not legal math. I mean, we were dividing this by h. All of a sudden we're taking the h root, it doesn't make sense. It's all because properties of logs. All right.
Are you teaching a main master class?
No.
He's teaching a summer, but it's online.
Okay.
No, I'm not ready to get some off.
Making sure I've got all things covered here. 213. Go ahead and for 6-5, do the homework out of the schedule that I gave you in the beginning of the class, okay? No changes to that homework assignment. Solving log and exponential equations. And this is really one of the main goals, all right, of all this stuff with logs and all these properties, is to be able to, in general, be able to solve an equation that involves exponents and logs. And I kind of alluded to this way back when we first started this. I'd given you a problem, and it was something we could do easily, right? Like 2 to the x is 8, versus something like, 2 to the x is 5. And those are completely different problems, right? But I had pointed out that the issue with this is that we're trying to solve for x, and x is trapped up in the exponent, right? And it said, how do we get x out of the exponent? We don't have an algebraic way of doing this. It's going to involve logs. We know that now. It's going to involve logs somehow. So we can do both of these. Let's just do them real quick. This one is 3, just by looking, right? This one, how could you do this one?
It's going to be log base 2, 5.
So you're coming in here and you're doing log base 2, 5 equals x. So that's you rewriting it from exponential form to log form, isn't it? Okay, I agree with that. Now?
The change of base.
Change of base formula from last class, where you use your calculator and your calculator only has that natural log key on it.
Right, there's a-
So this side turns into natural log 5 over natural log 2 equals x. And so you get your calculator out and you do that, right? And you get an answer. We good?
Yep.
Everyone have their calculator today?
Well, I
Good.
did bring my down.
Just double check it. Make sure you can get that answer. Where did this come from? I found this calculator in the classroom last semester. Some student left it behind. It wasn't one of my students. It was from a previous class or a class that was in there before us. I take it off, and there's like all these little cheat sheet formulas in here for like hydrobromic, hydro something, sulfuric, chlorine, all these chemical formulas and stuff in here. I'm sure they weren't using it to cheat.
Right.
All right, so what do you get? What do you get here?
2.322.
2.322?
Yeah.
Okay, approximately. All right. So are we all okay with that?
Yeah.
All right. Here's what I'd like for us to realize is on this equation right here, you kind of had two ways of doing it. One of them is exactly the way we just did it here, which if you're happy with it, good. But I want you to see another way because the other way might be more useful later. I'm going to take this 2 to the x equals 5. This is a second approach. And I'm going to use kind of not a trick, but the power of the logarithm here. What I'm going to do is I'm going to take the logarithm on both sides of the equation. Now this seems more like an algebra move, right? Like square both sides, subtract something from both sides, add something. You're basically evaluating natural log at both sides. So natural log of 2 to the x equals natural log of 5. Do you feel like that's a fair move? Just don't ever tell anyone that you are multiplying by natural log, because you're not. You're taking natural log on both sides. That would be more appropriate for you to say it that way than it would for you to be saying multiplying by natural log. With me? Now, does anyone see what I can do on the left side?
You can move the x to the.
You can
That's
move
right.
over.
I can move the x out front. Why am I allowed to move x's out front? Well, that's a property of logarithms, right? That if you have log of something to a power, the power can drop out. So you get an x to drop out front here. It's x times natural log 2 equals natural log 5. And then how do you get x by itself right here?
You divide.
Divide by natural log 2 on both sides. and you get natural log 5 over natural log 2, which is exactly what we just did over here. So you get the same answer, don't you? Right? Different approach. See, here I had to say, let me rewrite this in exponential form. In logarithmic form from exponential. And we use log base 2 here because that's the way we do it, right? But at the end of the day, it turns out to be the exact same problem.
Okay, so just a shortcut.
It's a different method.
I would see how this is a lot more powerful method.
This is more powerful because you need to always know that you can come in with natural log on both sides and pull powers down. That's more powerful than the conversion, just converting over to a different form. All right? So let's try something else. Let's try this. I want you to solve another exponential equation for me. Let's try 2 to the x plus 1. I'm going to do one, then I'll let you do one. 2 to the x plus 1 equals 5 to the 1 minus 2x. Ooh, this one looks messy. What I do want to point out is that if I asked you to convert this to log form, you would be in some trouble, wouldn't you?
Yeah.
Because you have two different bases, don't you?
But we can do the natural form.
But you can do this thing where you come in on both sides with natural log, can't you? Now, why did I use natural log on both sides?
Because it's
The basis.
Yeah, and because my calculator has natural log. So I know that if I bring the natural log in on both sides, I'm going to be able to use my calculator.
but not necessarily
I could come in with any log. It doesn't have to be the natural log. I could come in with log base 10. Because all logs have the same property, right? That the power comes out. So it's my choice. So by convention, let's use natural log. So from here, where can I go?
You bring them out front.
X plus 1 right here can drop out, right? 1 minus 2x can drop out. See, this is the thing that allows me to pull my variable out of the power, which was the problem we had before we started talking about logs, right? Like, how do you ever get the powers down? This is the way we do it. So I'm going to pull this x plus 1 out. Natural log 2 over here. And notice my use of parentheses.
I was about to ask.
Yeah, I have to have that in parentheses because it's being multiplied.
And we would just divide that by x plus.
Well, you're trying to get x by itself right now, aren't you? Because you're trying to solve for x. Believe it or not, looking at this, this is a linear equation in x. This is a number, right? Natural log of 2. You could just do that on your calculator and get natural log 2. Natural log of 5 is a number. So if I had a number right here, I distribute it through. I'm just going to have a number in front of x and some number and a number here. It's going to all be linear. We should all be able to solve linear equations, right? All right. You sound like you're waiting for the...
I'm waiting for it.
No, there's no wait. I just want to make sure everyone recognizes that's what we have now. It's a linear equation. But I'm not going to use my calculator yet. I'm actually going to distribute this through as natural log 2. So I'm going to go x times natural log 2 plus, what's 1 times natural log 2?
Natural log 2.
Just natural log 2 equals, now distribute here and here. You get 1 times natural log 5, so natural log 5.
Hold on, for the start of that with
Uh-huh.
x times natural log 2,
Yes.
is it important that that's x times and not x natural log 2?
Well, that's the same thing as this.
Okay.
It's some number that I don't know, x, times the natural log of 2, which is a number, but I don't care to write it as a decimal right now. On the right side, what do I still have over here?
Natural log 5.
Natural log 5 times negative 2x. So I'm going to write it like this. Negative 2x I could do negative 2x natural log 5. It doesn't matter how I do it. This is all multiplication. 2 times x times natural log 5. So what I've done is I've released the x's from the parentheses. And now I'm going to move all x's to one side, everything that doesn't have an x to the other side. So why don't we leave this x natural log 2 over here, bring the one that's negative 2x natural log 5 to the left, which would make it positive. 2x natural log 5. And then this natural log 5 I'm leaving here, but I'm taking the natural log 2 that was positive here and bringing it to the other side, which makes it minus. You still good? The whole idea of getting all x terms on the left side is so that I can do what?
Math.
Yes? These both have x, right? They both have x.
Can you just combine them like a normal?
So would it be like 3x? Well,
It would be a 3x?
No, but they don't have the same natural logs. If this was natural log 5, then yes, we could say 3 of them.
So do you use the condensation method where you,
Or is it 3?
Put 'em together?
well, no,
Because they're not the same log.
What are you trying to solve for?
X. So divide
Do-
by x.
Close, not divide.
Multiply?
I-
No, divide by.
GCF, factor x out.
Oh.
L.
Factor x out. Right, they both have an x? Pull the x out. And you're left with natural log 2 plus 2 natural log 5 equals natural log 5 minus natural log 2. Do you agree? We're good? Okay, let's see if you're with me or not on this. Okay, I'm ready to solve for x. I'm gonna isolate x. I'm going to divide by everything in parentheses on both sides. So the right side, natural log 5 minus natural log 2, I'm not going to touch. I'm going to divide by this big ugly thing, natural log 2 plus 2 natural log 5. Questions?
well, I would say you could cancel out the ln2, but there's a negative. That makes ln2. So
Yeah, you can't cancel this way because it's not multiplication here.
you have one big thing.
Let me just see how you do with this. That's a little hint as to where I'm headed here. Am I allowed to do that?
Yeah.
2 logs were on the top, subtraction between them. Were they the same base logs? Yes, they're base E, so I can do that? All right, what about the bottom? Are they the same base logs?
I'm gonna go to the, so it'd be ln 5 2.
5, 2.
Square that.
Ah, good. Okay, that right there needs to be pushed up first. 5 squared is 25.
So 2 over 25.
Is it 2 over 25?
No, it's
2 times 25.
ln50.
ln 50. Can you do anything to this? I don't know, I'm asking you. Do we have a property that takes 2 logs that are being divided and turn them into a single log?
What can't you do? Yeah.
Yes.
ln,
No. No.
ln,
No.
Yeah,
5
no,
over
you
2
subtract
times
the two.
reciprocal of 50
So going into 1 log from
over. So
here,
it'd be 5 over 100.
you think?
So then it'd be 1 over,
So it's just the fraction on
You
top.
you can't put these 2 logs together. See, look at our properties. Go back. You have to be careful with this. Our property said log base A of x over y became log base A of x minus log base A of y, right? That's the property. It says if you ever have division in a single log, you can split it into subtraction, or you can do subtraction into a single log. We have nothing that allows us to put 2 logs being divided together. We don't have a property for that. So That's your answer.
That looks like that would be a test question.
Yes. How do I get 50? Okay, so are you okay with that 2 coming up? As a power in front of a log, I can push it up as an exponent. So that's natural log 2 plus natural log of 5 squared, which is 25. And then I have 2 logs separated by addition. I can condense them into 1 log, but then I do addition turns into multiplication, 2 times 25.
Oh, okay.
And there you get the 50.
Yeah, I had to go back to the notes and double check.
Okay, your turn to do one. And then after you finish this, we'll call it a day.
You said that one time and that problem turned out.
Yeah, no. Yeah, you're right about that. No, I'll make sure this one's doable. It's going to be right out of the book, so it hopefully will be. It's very similar to what we just did. Okay. How about 3 to the 1 minus 2x equals 4 to the x.
No kidding.
You got about 10 minutes. For homework, don't start this section yet. Do the homework from 6.5, but don't start 6.6 yet. We'll finish that up at the end of the week.